Hello guys, welcome back to my YouTube channel. My name is Mike Mathukei and this is my programming series. We've been going through this programming series. We have been doing Python and C++, looking at various beginner concepts, and last time we looked at classes. So this time we're going to be looking at classes still, and I'll be introducing the constructor and destructor methods that we use in the classes. You would ask yourself, why do we have methods that are called constructors and destructors? So by definition, a constructor is basically a method that is called whenever you're initializing your object instance. Okay, so you have your class. So whenever you are creating an instance of that class, what is called is the constructor. And then the destructor, of course, will be the opposite of that, where when now you're closing your application, the destructor will be called, or whenever you delete your object, it will also it will also call the destructor method. So we'll just jump right in. We'll start with C++ as usual. Then Python, I'll put markers on this so that you can just look at the tabs that are available there on YouTube. There's a section that will be specifically for Python and a section specifically for C++ in case you want to jump around. I've also hooked up the link to the previous video up here, so you can follow up on that as well. So let's dive right in. So looking at C++, so this is what we had last time. We had a class called person, and we had a public variable that we call the string name. Then we had the private variables, which are the age and the weight. And then we added an m underscore just to mean that it's a member variable for each of these variables that we had. And then for the functions that we had our setters here, where we set the age, where we set the weight, and then we had our getters here, where we get the age and we get the weight. And since the name is public, then we are able to access it directly. So whenever we create this, we created this person here, and then p1.m name, since it's a public variable, we are able to assign the name directly. And then for setting the age and setting the weight, since the variables themselves are of a private nature, we need to use a setter. Okay, so so when it comes to a constructor, so in C++, a constructor is basically a function that first of all will not have a return type. So whenever you declare it, it will not have a return type, and its name is the same as the class itself. So here we'll have person. That will be our constructor. As simple as that. That's now our constructor. If I print something here, so we can say class constructed, like so, and then we run this, you'll see that the first thing that happens when we declare our object here is the constructor is called. So if you don't define the constructor manually, there's a default constructor, which is basically this. If you don't define it manually, it will just be, there's that default constructor that will be placed there. So in this also, we can be able to do initialize our variables at this constructor, which is mostly what we use our constructors for. So for example, if I say that here we'll receive, I'll just mix this constant. So constant std string name, and then constant int age, then constant integer weight. And then at this point, where we are constructing it, we give these values. So we have name is equals to name. Then we give age is equals to age. And then we give weight is equals to weight. So now in this, just a small note on this convention, you can see that since we have declared our variables here, name and so on, you can see that we are not conflicting in terms of the variables that you are also passing. It also becomes easier to have a standard name here, and then within the class now you use the prefix that we've used here. So for this one, I'll just remove this set age and set weight so that you can see how we're going to do our construction of the class. So when we do this, we'll do equals person, and then now we pass our name. So we've said Michael. We pass our age, which is any age, it doesn't matter really. And then maybe our weight, you can put 60. So this is how now you call the constructor of your function. You call it using the name of the class, and then with brackets you can initialize whatever variables that you need to. Okay, so here we are printing out the values. So if I run this, you can see that we get exactly what we had before. Everything is initialized at the constructor level. Okay, that's the function of our constructor. And then for the destructor now, we have this tilde sign that we use with the same name as the class, and also in the destructor, we do not have any parameters that are given. It just comes as is. However, this is always called whenever we destroy our class. So destroying usually happens maybe at the end of the application. We are no longer using this class anymore, so we destroy it. That's how that works. So I can just print here class destroyed, so that we have a distinction. And then if I run this, you'll notice that we have class constructed. Then now we print whatever is here in this sequence, and then at the end of our application, we have now our class is destroyed. Why? Because now we are at the end of our application, so our application is releasing every value in memory. And in the moment it's releasing these values in memory, it calls the constructor so that it can delete anything that is that needs to be removed. So we are here to look at heap allocation. There's usually different ways of declaring variables in C++. You can give it heap allocated memory, or you can use the stack allocated memory. So we have not looked at that yet, but in the case where you're doing a heap allocated memory, creating the variable is up to you, as well as deleting the variable is up to you. If you do not delete the variable, then the application will not know to release that memory even when you've closed the application. So that's something that we'll look at specifically for C++ in the future. But just so you know, whenever you have a variable that is heap allocated, it will be you'll need to manually define the deletion here in the destructor. Okay, so that's just something to note. You can try and research before it comes to the time when we'll be going through that topic. Okay, so let's look at the example of a constructor and a destructor in Python. So in Python, I'll just switch to Python. Like last time, we had this person, and then we had age, weight, and name. You remember in Python, you do not have public or private. It is just everything is accessible. However, there's a slight difference in the way these variables are. These are member variables in definition for Python. So our constructor in Python is basically you do def init self. Okay, so this underscore underscore init function is the default definition for our constructor. And then you can see we have self as usual. Whenever we have a method for a Python class, we must have self, which is the instance that is being called. Okay, and then in this case we'll also pass the age, weight, and name. Perhaps I can change the order so that we start with name, then age, then weight. And then so here we have something that we'll be looking at specifically for this, because there's something called instance variables where we do self.name equals name, and then we have self.age equals age, and then we have self.weight equals weight, right? So in this case, these are instance variables. They are called instance variables, and these are called member variables. Okay, so how we'd use them. So here I'll just remove this member variables for now before we get to that. So we have our constructor as usual. We have person here, and then we can now call, remember self is added there by default whenever we are calling any function from the class. So you don't need to write self as a parameter. And then now we can define our name. So let's say Michael, still use the same age, 22, and then we have weight, let's say 60 again. So this is one way that you do it whenever you're calling your constructor. And again, it serves the same function. It initializes the variables of the class. So another question you might ask yourself, so if you've done it this way and we've not declared the member variables like we had here, the name, the way we had here, name as string and all that, will they be accessible? Yes, they will be. So you remember in a Python class, everything is accessible from outside. Everything is public. So if I run this will be able to print exactly what we've written. So you can see Michael, 22, and 60. And then so allow me to also print this. So I'll just print a constructing class so that we know we are calling our constructor. And then now we can also define our destructor. So for the destructor, we use def underscore underscore delete. So delete here, and then so the destructor does not have a parameter. It does not take any parameter, okay, except the self, of course. And then from here now you can do whatever you're deleting. So for now we'll just say destroying the class. We can just print that out so that we know when it's being called. So if I run this, you can see we have constructing class. Then now we have the prints that we've done, and then at the end of the application it will destroy the class. I can see I've done a typo there, destroying the class. So at the end of your application, when the memory is being freed for that application, since it's being closed, the destructor will be called for that class, for any of the objects that we have. So that's how that works. Our destructor is basically called whenever we are destroying the object or whenever we are deleting the object. Okay. So the other thing that we need to look at is the member variable versus the instance variable. So the only difference between the two, so I'll create another variable here, which is a member variable, right? So let me just note that down, member variable. And then these ones are instance variables. Sorry, I got in the habit of using C++ there. So instance variables, okay? So the only difference between the member variable and the instance variable is the member variable is accessible through any object, right? So it belongs to the class and not the object itself, not the instance that has been created. So for example here, you see when we have this classification, right? So when we have this person, we can do person.classification is equals to maybe human, for example, something like that. But we cannot do this for an instance variable where we have, let's say, name. You see, it's not available. If you try to access age, it's not available, and this will definitely print an error because this age, it belongs to a certain object, a certain instance of the class, not the class itself. Okay, so that's the difference between this person, sorry, this member variable and the instance variable. So another question you must ask yourself: does that mean that the member variable is the same throughout all the objects? Then the answer will be yes. So if for example I create let me just give this a value from within the class, right? So we can have our classification is human, and then here we can create a second variable where I can say person, let's say Duke 21, let's say 50 or 40, and then now we can print the classification for P1, and then we can print the classification for P2. Okay, so when we run this, we can see that first of all we have a constructing class, so the constructor is called for each instance. That's first. And then second, we have for P1 and P2 we have human being printed. So if someone came here and changed person dot classification equals, let's say what word can we use? Maybe let's say dog. Just code. I hope no one named Michael or Duke is being offended by this. So you can see that the classification for both has changed across the two instances. So that will help you understand the difference between the member variable and the instance variable. So the instance variable belongs to a certain instance or an object, while our member variable belongs to the class itself and is accessible across all objects. So I really hope you have enjoyed this lesson. I hope you have gotten to learn. Those are just the small details about our constructors and destructors. We'll still be looking at classes in the next lesson. There's, like I said before, there's a lot that comes with classes. They can be very powerful, and if you know every bit of tool that you can use with it, you can really make a difference in the way you're coding. So I hope you've enjoyed this lesson. Kindly like, subscribe, and share. If you have a comment, please share with me. If you think there's something that you can contribute to the topics that we are doing here, please share. Special shout out to Peter Njoroge, who also mentioned something about the instance variables. It was to come to this lesson, but due to his comment, we are able to get to make sure that this was included in this video. Thank you guys, and see you next time.